So I'm going to show you how to do it. I'm not intending to test you on this, okay? So I'm not going, when I say I'm not intending to test you on it, I'm not going to give you a data set in a test and say, hey, smooth it. But I'll just show you how to do it because it's not terribly difficult. There's an explanation there. I think it's probably easier for you to read through that later. What I will do is show you an actual example. And I've put the data for this on Wattle. I'm not sure if I can share it. Let me try. Oh, here we go. Okay. All right, so I've just posted that to the chat in case you want to follow along. So this is what it looks like. So the scenario here is, I'll put it in the notes, I think. Yep. Okay. So this is a kind of situation I've come across a fair bit over the years. I've had students who have, I haven't actually come across it in a medical centre, but I have had more than one student over the years that was in charge of branches of fairly large bank branches, and they had issues about how long it took people to get served, at least back in the days when people went to the bank and queued up to get served. So the idea here is that there's a busy medical centre. It has one of those queue management systems where you go in and you take a number, and you sit and wait and you get called, and then you go up to the front and tell them that you're there, and they take your details and so on. Very common systems, and those systems many of them keep records of the time between the number being taken and the person being called. And then that provides data that can be used to track how well the system is going. So what we have there is a set of data over about 10 weeks, which is the data here is the number of times per day that a target of having a patient wait no more than 7 minutes was exceeded. So these are failures in the system, if you like. Okay, a patient is considered to have been failed by the system if they had to wait more than 7 minutes. So when you look at that data, I put in an upper fence line there, so this is a run chart. There's no outliers, so it appears to be in statistical control. But if you look at it carefully, it looks like there might be some sort of a pattern in there. There might be some kind of a cycle going on. So what we can do is to investigate that, and this is typically where you use these smoothing procedures. To investigate that, we can do a running median calculation. So if we go around to the data, so this is typical little tidy table. You've got an ID for each row, which is a little bit redundant because each row is actually a date, so the date can serve as an ID. Now you'll see there the date is in year, day, month, year format. So this is the default in my English copy of Excel. If I put a date in, that's what it turns it into. Now that is quite easily changed by going into the cell formatting menu. Okay, now what we just have to do is scroll down and look for the ISO standard version, which is there somewhere, usually. Where is it? Oh, there it is. Okay, so I just choose that. Okay, and so that's fixed that. So we've now got nice ISO dates. The one advantage of this is, what happens in practice when you're working with data is, at some point somebody's going to copy that and paste it into something, and the thing they paste it into, the software may or may not recognize whatever Excel puts into the clipboard as a date, and it might come out as some weird number. There are some very weird ways of storing dates in computers, and one of the most common ones is to store them as the number of seconds, I think it is, since the 1st of January 1970. So if you put it like this, this is fairly unambiguous, and it works if it's converted into text. Okay, so we've got the date, and then we've got the failures per day. So here's what we do with a, so the thing we're going to use is called it's called a 3R smoothing technique. And the way it works is you, in the simplest version of it, you just copy over the first number in your time series. And then with the second number, what we're going to do is calculate the median of those three. Okay, so this is going to become median, and then I'm going to highlight those three. Okay, so the median of 1, 7, and 3 is 3. And then once we've done that, we can just copy that all the way down, like that, and Excel will pop up a little message here to warn me that I haven't used the same formula in the first cell, so I have to tell the ever helpful little Excel not to do that. And then we have to go right down to the bottom, because in the bottom cell we have to copy that over. Okay. Now this
hi Ed, sorry, I have a quick question. How did you copy it all the way down?
Oh, good question. I learned this from a student. I used to, for a couple of years, I ran little courses for the ANU used to have it was like a management consulting club, it was called, and I used to do little courses for them, and one of them was on Excel, and I was doing this thing and, laboriously dragging and dropping things, and then one of the students said, look, all you do is you get your cursor and you see there's a tiny black box on the corner of that green box around the 3 there. If I hold it there, it changes from a white cross to a black cross. So you get it like that, and then you double click, and that just copies it all the way down. So I take my cursor, I put it in the cell I want to copy. I take the cursor, just move it over that little black square in the corner there, and it turns into a black cross, and then double click. And then I don't have to, but I don't like seeing all those little error things, so I'll get rid of them. And then we go down to right to the bottom, and we just we copy that value. Okay, so this is the most basic form. Now what there's a couple of refinements to this. So one refinement, the kind of standard or canonical refinement, is we don't just copy that number to there. We do a little extra calculation. So I'll do it. It's explained in the notes. So this first value here, this This is called the end rule. So what this is it becomes the median of the first number there to the left, and then the second running median number, and then we do a little calculation which is 3 times the second running median number minus 2 times the third one, and that's it. So if I just highlight what's going on there, it's the median of that number there, this number here, and then 3 times this number multiplied, 2 times the 7 there, subtracted from 3 times the 3. The practical effect of that is it just smooths the endpoints. So you can consider that optional, but it is the standard way of doing it. And then we kind of do the same thing at the bottom end. Oops. Okay. So all it's doing is it's just smoothing the ends. Now, so that's the first step. Now the R in the 3R there means that you actually repeat it. You repeat it until it converges. So let me show you what that means. So I'll call the next column, I'll call it 3RA. So all we do here is we copy the whole column and we paste it. And what that will do in a few places, that will do a bit more smoothing. Okay, so there's a number there, 16's been changed to 12, for example. And the idea is you keep doing that until there's no further changes. So to see if there are changes, in Excel you can do this little thing where you, I'll show you the formula. So it's equals that, and then, so what that is that is a formula which is checking whether those two are different to each other. And so it's false because they're both 1. But if I now do my little trick there and copy that down, you'll see it's found a few cases, quite a few there, where it's different. And if you've got a really long data set, you can actually add these up. Okay.
Please show me the first thing that you had with the median of the D. Is it D, the first 2 D's, and then
this bit. So sorry, this one. Is that the one you're asking about, Sarah?
The second one, E, 3RA.
Yeah, this bit here. Yeah, so this one looks a little bit complicated. So what we're finding the median of there is we're finding the median of that, and then a calculation involving these two, which is 2 times 7 subtracted from 3 times 3.
Okay.
And then it works in the opposite direction at the other end. So that's the canonical way of doing it. Now what I was I'm trying to remember what the formula is. There's a formula you can use to is it F2 to F3? Okay. There is this countif formula you can use to count how many trues you've got in that column. So what that means is because what that means is we probably should do a 3RB. We should probably do another one. So it's just copying again. We just copy and then we paste. Okay, and there's a little bit more smoothing done, and we can check that again. And this time, okay, so there's still, you can see there's still a few that it hasn't smoothed. So just do it again. I don't think, in my experience, I don't think I've ever had to copy it more than about 5 times. It tends to converge fairly quickly. Oops, what happened there? No. Okay, we'll do another one. And I think we're done. Okay. All right. So 3RD is our final version. Now what I'll do is just bear with me a second. I will attempt to do a couple of charts here just to show you the effect of that. Okay, so let's get that there. So that's the original chart. And a bit of fiddling here. I should be able to. Alright, so you can just you can see how it's smoothed it, and what you can see there is pretty clearly some sort of basically month-long cyclical pattern there. Now there are lots and lots of ways of smoothing data. So the method I've just shown you, the reason you'd use that is it's kind of transparent, because if somebody asks you how did you smooth it, you can describe it exactly, and you know what it does. You know it's a running average, it's a running median. Okay, so it's kind of easy to understand in that sense. It doesn't generally throw away too much information. So you can get techniques. I'll show you. So Excel has a number of tools for for smoothing things. Let me just see if I can show you. Where are we? Okay. So I've just clicked on that chart there. You can add what's called, in Excel they call it a trend line. If you go down to trend line options, you'll see a bunch of them there. So you can get a moving average. So like most of these statistical things in Excel, it's not very well documented, but I have attempted to sort of reverse engineer this, and I'm pretty sure it's just a moving arithmetic mean. I'm just going to try and change the color of it so you can see the thing. Okay, might be a little bit better. So you can see there that it's so that's a moving mean. The moving mean's not too bad. The problem, and it's not obvious here, is it's overly influenced by outliers in the data. So if you've got outliers in the data, a moving arithmetic mean is going to get pulled up too far or pulled down too far. But Excel has a number of others that can be useful in certain circumstances. So it has one called a polynomial, and what this is doing is it's fitting a polynomial equation that goes up to about sixth order. So that's, you know, x to the sixth plus something times y to the fifth plus something times z to the fourth, and so on. And you see, if we use a sixth order polynomial equation, it gives us a lovely smooth line there, which essentially parallels what we've found from the running median, but it's thrown away a lot of information there. Probably, I would say, too much. It's thrown away too much information for most exploratory data analysis purposes. But it might be useful in a presentation if you want to just show an audience, look, this is the general trend. There's this, approximately monthly cycle. And there are many others. If you get into more sophisticated software, there's all kinds of very fancy smoothing things. But the running median is just, it's pretty simple to do. It's very well understood. It's used for lots of things. It's actually used in image processing and sound editing and things like that as a way of separating a signal from a noise. It's basically a signal processing or a signal filtering algorithm. But I thought I'd show you that because it's just something you can do pretty quickly, and you can kind of have confidence that you're not doing too much damage to your data by using it. It'll often help you see a pattern, but without throwing too much away.